Hi, welcome to this module on statistics. In this video, we shall be talking about the population sampling. What do you mean by population sampling? Analyzing or testing entire population is impossible and also a cost and time taking process. To save our money and time, we use the subset of the entire population called as sample. Population sampling is the process of selecting a subset of the objects that is representative of the entire population. The sample must have sufficient size of objects to warrant statistical analysis. Must be performed correctly since errors can lead to inaccurate and misleading result. Now this particular table will give you an initial idea about the mathematics behind it. You can see the first column, which is population or sample. The first category is population and the second category is the sample. There are various terms inside population: population size, population mean, and population variance. Similarly, we have sample size, sample mean, and sample variance. Now, before talking about variance, let's talk about standard deviation. Standard deviation. Well, I will have a detailed class on standard deviation in one of our future modules, in one of our future classes. But standard deviation simply means it's a measure of how spread out numbers are. It is usually symbolized with this, which is called as sigma, the Greek letter sigma. The formula of standard deviation is very simple. Standard deviation is nothing but the square root of variance. But what is variance? Variance is nothing but it is defined as the average of squared differences from the mean. Now, if you talk about this formula, variance is simply summation of xi minus mu square divided by n, where summation simply means the combination, the addition of all the values. Xi means the original data point, and this symbol, which is called as mu, is nothing but your mean value, or in simple terms is called as average. So variance formula is this. It is the summation of xi minus mu square divided by n. That's all about variance. Size basically means the number of items or elements in the population, and mean is the average value. If you closely look at the formula of population variance and sample variance, there is a minute difference in the denominator. In population, in the denominator we have n, but in sample we have n minus 1. The reason behind this will be explained in one of our future videos, but as of now, just remember this thing. Population variance is something like summation of xi minus mu square by n. If you have 100 records in your population, this n becomes 100. If there are 10 records in your sample out of population, then the variance becomes xi minus mu square by 10 minus 1, which will be 9. Okay. So that's all about this particular slide on population sampling. Well, I'll try to quickly explain a small example using the mathematical formulas. Let's say I have few records 5, 10, 15 and 20. What is the addition of these numbers? The addition of these numbers are, let's say one more, 30. 5, 10, 15, 20, 30. If I sum it up, it becomes 50, 55, 65. So it becomes 5 plus 10, 15 plus 15, 30, 80. So it becomes 80. Now 80 divided by 5, what will be the average value? It will be 16. Now what will be xi minus mean? For the first record, it will be minus 11. For the second record, -6, third record, -1, fourth record, 4, fifth record, 14. What will be xi minus mu square? So this becomes 121, this becomes 36, this becomes 1, this becomes 16, and 14 square becomes, I think, 196. I hope everybody knows that the square of a negative number is always a positive number, right? So this becomes my xi minus mu square for each of these entities. What will be the sum of these values? So the sum of xi minus mu square will be 121 plus 36 plus 1 plus 16 plus 196. If you add it up, 196 plus 16 plus 1 plus 36 plus 121 becomes 370. So if these 5 records are part of my population, then the variance becomes summation of xi minus mu square divided by 5 root over. This becomes, sorry, not root over. If it is root over, this becomes a standard deviation. Let me write it down, standard deviation. Okay, which becomes 370 by 5 root over, which becomes 370 by 5 is simply 74. So 74 is my variance, and my standard deviation is the root over of 74, which is somewhere around 8 point something, 8.6. This becomes your standard deviation. Now, if these 5 records are a part of your sample data, not a part of your population data, in that case, the standard deviation formula becomes 370 divided by 4 root over. So 370 by 4 is around 92.5. Root over will be, 92.5. Root over is 9.6. 92.5 root over is 9.6. So here the variance becomes 92.5. The standard deviation becomes 9.6. So that's the mathematical way of understanding different concepts. Well, the why part is still not clear, but hold on, we have a separate video for that. That's all about this particular video on population sampling. And trust me, the mathematics and the all this kind of calculations part is going to be even simpler and simpler in our future videos as well. I'll try to simplify as much as possible. So that's it about this particular video. See you in the next video.